Hello, my name is Zachary Hall. I'm inside of Professor West's biomechanics class, and I'm here to talk to you guys about the leg extension. First thing, I'm going to talk about the kinetics of the leg extension. It would be the flexion of the rectus femoris, and here's a diagram. So right here would be the rectus femoris. Then you got the flexion of the vastus medialis right here, and then the vastus lateralis. As these muscles flex, it causes the knee to pretty much start to extend in an outward motion. In order to get the full flexion of the leg, dorsiflexion, which is the flexion here, is needed, plus the contraction of the tibialis anterior, which is this muscle right here, the extensor digitorum, which is this muscle here that runs all the way down to the beginning part of your tibia, and then the peroneus longus, which is this muscle right here. Now I'm going to talk about the kinetics of the leg, and the kinetics of the leg extension is understandable by the motion. As the muscle contracts, the muscles then shorten, causing the leg to extend fully, as you can see here. So as the muscles flex, right here you can see to where they're flexed, dorsal flexion of these muscles, the leg will fully extend. The next thing I want to talk about is the lever systems. The lever system of this exercise of the knee would be the knee joint. The knee comes with stability. One thing I want to mention with the stability of the knee would be the ACL, which would be the anterior posterior ligament, which runs anteriorly, and then you have the posterior ligament, which runs this way with the knee, and then you have the medial ligament, and then you have the lateral ligament. This way it holds the knee in place, it holds the stability, so you can do all your twists, turns, you can plant, move. Basketball is a really good aspect for this because it demonstrates the ability of the leg moving in very many different ways: stop, turning, planting. The knee can't go past this current extension with the laws of motion, mainly because if you go past, as you can see here, if you go past the extension part, it won't go because of the flexion of the muscles. And of course you have your ACL and your PCL, which are keeping it in place. If it went past this area of extension, it would cause hyperextension, which would lead to muscle tearing, maybe possible ligament tearing. The next thing I want to talk about, which is the range of motion of the knees. The range of motion of the knee is very basic when it comes to like determining like ACL rehab, meniscus reconstruction, ACL reconstruction, PCL reconstruction, anything along like any type of major reconstruction with the knee. With goniometer, the degrees the knee is for the range of motion for flexing. So as full extending of the leg, it would be at 180 degrees. As for full like flexion of the leg, it should be around 0 to 30 to 40 degrees, depending on how dynamically flexible people are. Anything past this is considered like hyperextension or anything like that. The next thing I want to talk about with the motion of the leg extension, I want to talk about the bones of this. So for the bones, I talked about the muscles, I talked about the ligaments. Now I'm going to talk about the bones. So here you have the femur that runs all the way down and all the way up to your hip. You have the patella right here, which is attached to the tibia and the femur through patellar ligaments. You have the tibia, which runs all the way down, which is also called your shin bone. And then you have your fibula that runs here along this side. I hope you guys enjoyed, and that's all I have. Thank you.